Hello, this section is entitled Core Concepts, Understand Services and Other Network Primitives. So in the previous videos, we saw first how pods are essentially mortal, right? That they can die at any point. So that's one thing. So to get around that, we introduced deployments, which allow us to run a number of these pods and maintain them. But the key here is while we're maintaining the pods, their IP addresses are continuously changing. So the question then is, let's say we have a server, we want to treat those set of pods as a singular service that we can get, maybe a website from or an API from, right? The question is, how do we provide a consistent way, an IP address, say, that front ends all the various pods, and that way our code only has to refer to the singular IP address, right? And that's essentially what a service is going to do. It's going to front end our quote-unquote backends, which are our pods. Now, I think the easiest example, way of understanding this is just do a simple example, and so that's what we'll do next. So first, let's look at the code for our first example. So the one we're going to first look at is the service selectors, and that closely aligns with what we just talked about, and we'll talk about the other one shortly. So in our templates, right, first thing just to set this up, I created a pod, it's just an Ubuntu pod. I'm going to use that one to test my service, so it's going to be like the client that consumes the service, right? And then there's a deployment, and that should be familiar. It's exactly the same deployment we've been doing. This is in theory, right? I mean, in terms of a deployment. The only thing that's different here, though, I did switch to using a web service, right? Because I wanted to test out this being a real service that provides, some functionality. In this case, it provides on port 80. It provides, basically hello world web page. Right? So that's your deployment. So I'm going to have 3 pods running around with 3 different IP addresses, each of them running essentially the same thing. Right? Now here's the new concept. It's a service, and the main characteristics of this, right? You get your label and stuff like that, but the specification is a combination of 2 things. One is you need to basically specify a label selector. In this case, I use the same label as the deployment. So this is looking for pods that have this label, essentially. And then the ports are, this one only has one port, right? Port 80, but it can be multiple ports. And the idea is these are the ports that your service is going to listen on and where it's going to get redirected to on the pod. Now, I don't have in this example, but you can actually specify a target port also. So let's say you run your backends all on port 8080, but you want to make your service available on port 80, you could also provide a target port here. If you don't specify it, they're the same. So in this case, what I'm doing here is I'm creating something that's going to front end my 3 pods, so it expose itself on port 80, right? And it's somehow the traffic is going to get to those pods. Okay, let's see how all that works. So, close out of this. Okay, I think I want to install it. So, helm install dev service selectors. And we'll explore it. Okay, so first thing I'm going to do is just do a quick gut check to see what got created. So let's kind of start from maybe bottom up, or actually I'll start with the deployment. So there's my deployment, right? And my deployment created its replica set, which then deployed to 3 pods. So that's good. There's my Ubuntu pod sitting here. Maybe I'm going to log into that one shortly. And then the new thing is right here. There's an example dev, which is a service now. That's something new. And the key one of the key features of it, it has an IP address. And you notice it has this 10 address. So these IP addresses are distinctly different than the whole pod networking addresses that we used previously. This is obviously not part of the 192, I forget what address space it was, but it wasn't 10. So this is a sort of a virtual IP address that it's using, and we'll explore how that IP address can be used. And also you can see there's port 80 down here too, right? So let's go, let's describe the service. Yeah. Just to get all the detail. Describe service, example dev. Let's see. So if you look at this, one of the interesting things here you see is, you can see that there's port and target port, right? And here are the endpoints, because this one, when it ran, right, it found the pods in question, and so it created basically these things called endpoints, which are the the back end pods that it's going to send traffic to. So, and then the last thing we'll do is we'll just get the service in detail. So kube control get service example dev, and it's just a more detailed version of it. Actually, it just doesn't have a whole bunch of detail, to be honest. Yeah. I guess the one thing I did want to see here, actually, I think that's the reason why I did this. See this type here? We didn't specify a type in our example. And we'll learn that there's other types of services. So this is like kind of the cluster IP is kind of like the base building block, the simplest version and a default version. And we'll add some other complexities later. And so that was, I think, one point here is that this is called a cluster IP type. And essentially, again, it's going to behave like an internal load balancer. Okay. So, make sure I'm not missing anything. Nope. Okay, so let's, we're going to log into this Ubuntu, and we're going to try to use this cluster IP service and to see how, like, what the whole point was. So I'm logging into my Ubuntu example. Now, in order to do this, I need to actually install some tools. So let's get this done real quick. Apt get install DNS tils. Apt get install curl -s. Okay, that should only take a second. Okay, so the first thing we can do, there is an IP address. I don't think I probably have it on my screen here. Well, if you recall, let me exit real quick. Okay, so there's an IP address. I'm going to copy this IP address. Copy, right? And let me go back to my container in my Ubuntu, right? And if I do curl on this IP address, there's my one. Basically, curl basically is a command line tool for opening web pages. It goes to the web page, hits the 10 address, right? And then it basically proxies and sends the traffic. Itself will basically get the web page and send it back to me from one of the back ends. So essentially how it's working. So I'm talking the 10 address. Behind the scenes, something else is acting in between me and the endpoints, getting this data to me from one of the pods, right? Now, this address, this approach, hitting with an IP address like this is not very useful, because this IP address, I didn't know what that was in advance, one, and potentially that can change. So this IP address is not the most stable way of referring to the service. So this is where like the service discovery features come in to play. So one is, if you print your environment variables, right? If you start your pod after the service is up, which is oftentimes the case, then your pod gets, when it starts up, it gets basically environment variables. So for example, in example dev service, let's see, if I look at example dev, it's in different places. So there's, yes, right, here's example dev service port. Oh, here it is right here. An example dev service host, right? Actually, I picked the wrong one though. Where's example dev service host? There's just a lot of detail in here. Example dev, okay, I'm gonna do, this is grep example. It's hard to see all this in the noise. Okay, there we go. So now we're just looking at the things. So here is my example dev service host, right? So that's IP address, and that's the port that's running on. So now my code, I can in theory refer to example dev, these environment variables, to figure out where that service really is, so I don't have to use IP addresses. Another helpful way of doing this is NSLOOKUP. So if you have DNS installed in your cluster, right, then you can look up the service by example dev, right? And you can see the full name is actually example dev, which is the name of the service. This is the namespace, and then it's service cluster local. Just so you know, you can shorten. The reason why you shorten this, it looks like my my Ubuntu image, right, comes pre-shipped with a so instead of having to use the full name, it actually came with etc. resolve comp. So it looks like it has actually a default search, like search subdomain, and it has all these common Kubernetes default service cluster local, service cluster local. So I can do NSLOOKUP on all sorts of variants of the name, including just the service itself. Now curl, right? So the whole point of this whole exercise was to hit it. So I should be able to do example dev.default service cluster local. I got it. I can also shorten this to this, because that was one of the shortened versions. And it resolved that this should automatically append on the appropriate end of it. Now it turns out, for whatever reason, and I'm not sure why, but curl does not like when I just give it like that, it doesn't, if I had a period, no. It does not like just a single name, even though NSLOOKUP does seem to like it. So if I use NSLOOKUP on example.dev, it's happy. So this may be just a curl thing, because if NSLOOKUP resolves to it, then curl should have been able to figure it out. So I think that's just a curl thing. So you could just use the service name itself. Okay. Okay, so we're going to change gears a little bit here. So let me get out of here. And let me get rid of this helm uninstall dev. Okay, so in this last example, what we did is we had an IP address, right? The cluster IP was basically front-ending pods. Now, it turns out that there are some scenarios where maybe you want to create an IP address, like a service, right, that front ends external websites or external things outside of your cluster, or outside of, right, so outside of, basically not in pods, right? There are examples of this in the documentation. Say, for example, if you want to refer to an external website completely, and maybe in development you do it from external website, but then maybe in production you go into it's an internal service, right? So depending on your environment, you may have different backends, but you want to just maintain a consistent interface for your codes. You're always referring to it the same way. So that's probably the most common example. The example we're going to do now, I'm going to do this. I have another example here. I'm going to have a cluster IP address internally refer to an external IP address that's like on the public web. So that way, the backing service is really just a public website out there. So now, how this works I'll just walk you through the example. If you looked at the way we did, the name is somewhat suggestive. In the service previously, right, we actually had an endpoint, not an endpoint, so we had a selector entry here, and that's how it basically used that as a label selector, right? It found the pods that way. You notice that this service here doesn't have a selector, so it's not immediately clear, well, how does this thing, where's it going to? I know it's listening on port 80, and it's going to try to send traffic to port 80 somewhere on the target, but I don't know what the targets are. And the way you do this is you provide a second Kubernetes object called a endpoints with an S, right? And that endpoints has to be named the same as your service, right? So that's the same name as my service. And then here, basically, I'm providing these, the back ends. So in this case, an IP address on port 80. So I can have multiple entries here, right? And for different, different back ends. In this case, this is actually, I had looked up a website that did not run HTTPS, mostly because without HTTPS, this is not going to, anyway, if I use HTTPS, then I'm going to have like certificate issues, right? So this is actually silly.com. Apparently, silly.com does not use HTTPS. So I looked up that IP address using NS lookup, and then I put the IP address here for silly.com, right? So this basically will now have it. If I go to the cluster IP address, it's really going to proxy the traffic to this 50 address and then return the traffic to my service internally. So let's just do this example. So you notice there's no deployment here, and the only pod that here is for troubleshooting purposes. So if I do this, I do, what am I doing? Helm, install, service, no selectors. Oh, gotta put a dev in here. Okay, so let's look to see kube control get all. So what do we here? We do that again. So clear. Oh my goodness. I keep on trying to get a clear screen, but oh well. There's my pod that's running. That's my Ubuntu pod, right? There's no deployment, so I don't have all that stuff. I just have the service, so it's running on an IP address here. Endpoint is not showing, but I could do kube control get. I wonder if it's just endpoint. Oh, it is it, right? So there's my example dev endpoint, right? Or endpoints, right? Okay, but okay. So more importantly, let's look to see how this is actually used, right? So what we want to do is we want to log into the kube control exec. I'm going to copy it. Oh, I guess I didn't. Oh, I'm going to have to do this manually. Okay, so we want to. Okay, so let me do this for memory. Okay, I want to log into the Ubuntu pod, right? So that's going to be example dev. I want to log in interactive terminal. I want to run bash. And I want to do apt get update, because I want to install curl essentially. Apt get install curl minus yes. And if all goes well, I should be able to curl, see if I get this right, curl, the service name was example dev, and because I have to do, that should have done, yep. So notice I got back a web page, and if I look carefully at the web page I got back, this is actually, there's a lot of stuff here, but, oh, right now, wait, here it is. If you look carefully, this has got silly.com somewhere. Silly jokes, right? So this is basically the silly.com website. I'm accessing it though through a local service, which means the DNS name I'm using is this, and which is basically resolving to the IP address, which is internal, and then it's getting proxied out to silly.com. Okay, I think that was it for that. So let me leave this alone. Okay, so this is, I think the rest of this section is more theoretical and without an example, right? So the first thing you think about, though, is how in the world, so let me just get this back on the screen. Cube control, get all. So I've got this IP address 10.100.125.196. And we previously learned about how the pod networking works, where pods get their own IP addresses, and there was entries in our routes table that were getting traffic to between the pods. But how does this 10 address? I mean, this address doesn't look familiar. It's not part of the same name, the numbering that we were seeing earlier. How does a pod, right, get to this 10 address? So there's under the hood. So this behaves kind of somewhat differently the way the pod networking works. So there's a service called Proxy that's running on every node, right? So that was something we learned previously. And what happens, it's a very active participant in this. So what happens is, as a service gets installed into the cluster, Proxy, right, on each one of the nodes, is basically takes that IP address and says, oh, I need to do something with this, route this traffic, right? So and then there's different ways it does this, depending on how your cluster is configured, and we'll go through kind of the three examples and see if I can explain it properly. So in the case, there's one mode called user space proxy mode, which I don't believe is used currently. I mean, at least the two clusters I saw, this was not being used, right? So I don't think this is the default implementation anymore, but this is one of the patterns, right? So what happens is, what Proxy in this example does, it actually enters an entry into your IP tables, right? That says, hey, if traffic goes to this address 10. Blah 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 blah, send it to me, and that happens in every node, right? So then what happens at that point? First part of this is that every time there's something on one of the other pods hits an IP address 10. Something, that traffic gets sent to Proxy, right? And then Proxy internally manages. It knows about the services and knows about the backend endpoints, and it like routes the traffic or proxies the traffic directly to the pods, right? So that's one pattern. The problem here is you got this, I think it's called user space, because it's relying on a user process to do this proxying to these backends, right? So this might be slow. Another pattern is a little different. Proxy is still active participant. So when a service comes in, what it does is it installs entries into the IP tables, which is a more, I won't say kernel, but it's definitely a more like down lower service, right? And it inserts IP tables not to itself, right? But it actually makes IP table entries to go directly to the nodes themselves, to the pods themselves. So then when the client now sees that 10 address, right, it doesn't flow through Proxy anymore. It goes through the IP tables, and then that says, oh, there's a mechanism within IP tables to redirect traffic, or basically this could do a NAT translation to these other pods, right? So this is another pattern, and I think it's called destination NAT is the IP tables feature that's being used to make this work, right? So it's doing very much the same thing that Proxy was doing, but it all happens kind of in this IP tables world, which is much closer to the OS on your node. Okay, and then the last example, I don't have a good diagram for it. It's called IPVS, which I believe is IP Virtual Server Proxy Mode. It's basically the same idea as this pattern where Proxy is manipulating something in your node, but it's using a more kernel, like a deeper service that's more performant and closer to the kernel, I guess. and it's called IPVS. Now, I'm not going to do an example of that, and there are actually articles around that talk about IPVS in cluster load balancing deep dive, and you can read about that on your own. But it's generally the idea is, from what I can gather, right, the problem that IPVS solves is that if you start having a lot, all the things I've seen at least, if you have lots of services, like 10,000 services, apparently the process of updating this IP tables gets to be slow because wasn't really designed for this purpose. And so that becomes a problem, taking 10 minutes to deploy services. And apparently this IPVS proxy mode is super performant, and it just basically completely eliminates that bottleneck. So I think that's the main point. And the last thing I wanted to do is I was trying to figure out which of these three mechanisms AWS was using, and kind of a bit of poking around, I eventually figured it out. Let me just tell you how I figured it out. So let me do these commands, see if I can recreate what I figured out. Let me paste the command and I'll talk about it. So remember I told you it was kube proxy that was running on every node that was responsible for all of this, right? So I figured, well, look at, and it's a daemon set because it has to run on every node, right? So I'm basically, and it's part of the kube system namespace. So I described that kube proxy, and long story short, I looked at this and what it was actually running, right? And you can see that it's running a config file, basically, that's in this folder. And we haven't talked about volumes before, but there's a mechanism by which you can create volumes on your pods, which map to other things. In this case, I'm not going to get into the details of it, but there's a config map, which we do know about, that basically is the configuration for kube proxy. So without going into details of how that actually happens, we'll cover that later. I'm just going to look at this config map, and we'll see something interesting in that config map. So this basically is the config here for kube proxy. And in here, so this was, what did I do it by? The describe config map called kube proxy config. I mean, it's pretty obvious what this is. And it's in the kube system namespace. And in here, there is a mode. And I noticed the mode says IP tables, which is one of the modes we just talked about. So, and then if you just do some Googling, you find out that it seems like it does run in IP tables mode. And some people have figured out how to run on AWS, where it runs like in this more advanced or more performant IPVS, but apparently it's not supported yet, at least from what I can gather. There's some open issues where people are asking that there be official support for IPVS on Amazon EKS. So apparently doesn't do it now. Now the only other thing was, I want to just make one point of clarification too, because I was getting confused. So previously we talked about the CNI, which stands for Container Network Interface. I want to make a point, is that's a very different thing. That is all about how the pods communicate amongst themselves. That's completely independent of how the service networking works, right? That service networking is all about these three things. And then the way that pods communicate themselves under the hood is more about the container network interface. In this case, we were using the Amazon VPC container network interface, and that's why we're getting different sets of, that's what the old 192 address space was. And remember, whenever you get a pod gets an IP address, it's really out of the subnet, the same subnet that the nodes are running on, right? So I just want to make sure mentally disconnect the way service networking works distinctly from how pod networking works. Okay, so that was really all I wanted to cover in this video.